Okay, you're welcome to episode 4, right? So we want to uh, explain the meaning of logarithm. So when you hear logarithm, what comes to your mind first? Uh, there's nothing much about logarithm. Is like we've said before, is just an index. What we're doing here in logarithm. The idea of logarithm is actually gotten from square roots. When I say find the square root of 4, you will say the answer is 2. The reason why you say the answer is 2 is because you try to process a particular number. You can multiply twice, 2 times, to obtain 4. What is that number? Because the concept of square means 2, right? What is that number I can multiply by itself to get 4? So that was why you say 2 is that number, because you already know that 2 times 2 will give you 4. So 2 is that number that you can multiply by itself to get 4. So that is the reason why you said that 4 square, the root of 4 is 2. Another way again that you might have seen this, or possibly you are processing, is the idea of square means the index of square, right? The idea of square root means square. So let's say, for example, now I have square root of 4 is equal to what? So what is the base of an index 2 index? That is if I say x square, because this square means that's the idea of square root. What is the base? Because what we have here is base, like what we said in when we are studying indices. We're saying that this is called base, this is called index. So what is the base of an index 2 that will give us 4? What is the base of an index 2, that will give us 4? So you now say 2 is the base of an index 2 that will give us 4, that gives us 4. So the square root of 4 becomes 2. Remember, what we're doing here is, what is the base of an index 2 that gives us 4, right? Now let me also put it this way. If I ask you also, if I change this 4 to, let's say, 9, let's say 9, the idea of square has not changed. It's still the of what is the base of an index 2 that gives us 9, right? You start looking for the base of an index 2. That means, when we say index 2, mean x times x times x. So what is that number that when I multiply it by itself, I'll get 9? So you begin to process it. That's okay. If I try 1 square, I won't get 9, I'll get 1. Because 1 square is 1 times 1, which is what? 1. If I try 2 square, 2 square, I won't get 9, I'll get what? Because 2 times 2 will give me 4. Now, what if I try 3 square? The answer is what? 3 times 3, that gives us what? 9. So now the idea, now 3 is that base, because we got 9, is that base of an index 2 that gives us 9. So in square roots, what you are doing is you are looking for the base of an index that gives you, of an index 2 that gives you that number inside. So now for logarithm is the other way around. Yeah, for square roots, we're looking for the base, whereby for logarithm, we're looking for the index. Like, for example, now, if you were given, you say log, if I say find log 2, what I'm doing now, naturally, in a calculator, when we hear log, we're talking about base 10. Base 10. Now, base 10. So now, those are square root means square, right? Log means 10. Logs means 10. So we're now looking for what is the index of 10 that will give us 2. So here, index of 10 I'll give us 2. Just like we have here, the base of 2 that gives us 9. Here is the index of 10, right? That gives us 2. So we'll start processing it. Now, it will be, if we start looking for index of 10, you can punch your calculator. Let's say if we have 10, we have 10, if we 10 raised to power 1 will give me 10. I have exceeded 2 that I'm looking for. So I cannot use 10 raised to power 1 again. I have to come down a little bit. Now, if I punch 10 raised to power 0, I will get 1. I've started 1. That means, but I'm looking for 2. So I have to keep increasing this. But 10 raised to power 0 is 1. Remember, we're looking for the index of 10. So if you don't want to calculate it using a calculator of 2, you can process it this way. It's okay. 10 raised to power 0 is 1. I'm looking for 2. So what do? I have to, if I add anything to this, if I put 1, I'm getting 10. I've exceeded. So it means that I can start reducing my work. We're going fully aware that the index that will give me 2 is between 0 and 1. Between 0 and 1. So anything in between them is actually where the index of 2 should be found. So you begin to process. Okay, 10, 0 point. What if I type 0.1? What will be my answer? My answer would be, so if I now try if I try 10, if I try 10 0.1, 10 0.1, 10 index 0.1. See what I'll get. I'll got 1.2, 1.2, 1.2. So, but I'm looking for 2. So I will continue. It's okay. I'm almost getting it. So if I increase this one now to 2, so this is the idea of if I increase that one now to 2, 10 0.2. What will I get? I will get 10 index 0.2. See what I'll get? 1.5. I'm almost approaching that. So I keep increasing. If I turn it to 3, unko. So 10 index 0.3. What will I get? 1.9. I'm almost approaching that. 1.9. So that means it's between 1.9. I've started looking at 0.3. Now I can now continue again. 10 index 0.44. What is my answer? 2.5. I've exceeded 2.5. So I won't use 4 again. I will stop at 3. So what I will now do is that I will add something to this 3 and say 1. Say 10 index 0.31. Sorry, 10 index 0.31. I have 2.0. So it's possible that my log here is 2.0. Now, the idea of log, so that is the index. So 10 index 0.31 is 2. So when you now hear, if you ask to find log 2 is around 0.31 something. Now, look, let's go directly. Now, if I punch my calculator now, say I'm looking for log 2, see what will now happen. It must be around 0.39. Now, see. I have 0.3. Are you seeing now? 0.30. So it means that is the idea of it means I'm correct. So when you hear logarithm, we're talking about the index. What will be the index of that number on the base of 10 that will give us that number? So we're looking for the index. While for square, you're looking for the base. So these are the two different things between the logarithm and what do you call it, and square. So the idea of logarithm is we're looking for the base, right? We're looking for the base. Like if I say 10 raised to the power 0 is 1, right? Now why is it 1? It's 1 because the index log of log of 1 is 0. That's what it means. Log of 1. The value of index value of base 10, because that is what log means. Log means base 10. The index value of base 10. Remember when I say base 10, I mean if this is 2 square, 2 is the base. Why 2? Sorry, let me use another number. Let's say I have a, let's go b. A is the base, why b is the index, right? Good. So what log means is base 10. So the index of base 10 that gives us 1 is what? 0. Is 0. So that is what it means. So now that is the idea behind logarithm. So each time you hear logarithm, that should be what your mind should go straight. So this is what you do. Sometimes, so if you're asked to find log, let's say find log 4, log 4, what they mean is that of what index of 10 gives us 4? Of what index of 10 gives us 4? So another way of writing this is of this is like this. Of what index of 10 will give us 4? Of what index of 10 will give us 4? So you begin to track it. So this will be difficult for you to start tracking. That's why calculator. So when you punch your calculator, what calculator does is it will just help you to process the value of the index of 10 that gives you 4. So you start processing it. Okay. I have 10. I'm looking for 10. I know that I cannot for 10 raised to power 1 is 10. So I have to come down. So it will be 10, right? Index, let's say 0.6. And let's see what will happen. I got for 0.6 I got 4.5. So I can come and say 10 index, let's say 0.6. Let's see what will happen. I got 3.9. So it falls between 0.6666. So even if you don't want to go, even if you do so, the answer must be around 0. I'm sure of 6 will begin it. So I'm looking for an index. This is tracking, I'm tracking it. So, but if calculator, you wouldn't want, because that's why you use your four-figure table to do that. If you are doing that to start tracking, it will be difficult for you to get to the answer. So calculator helps you to do that. Just say log 4. Log 4 will just give you the answer 0.6. There is no two way about it. 0.6. You see. So that's the idea. That's a complete idea about logarithm. So in your new general mathematics, like we've been doing in SS1, what we're trying to is to understand all these topics so that it will be easier for you to solve it. That's what they mean by when you are asked to find the log of this, find the log of that. What they mean is that the index of base 10 that gives you that log is what? The index of base 10 that gives you that is what? Is what? So you begin to process the index of 10. Now, for anti-logarithm, which we're going to come in our next class, I will explain that one too, so that you will, when we are done, we can now start going into problem solving. If you are new to my channel, please do well to subscribe, like, and share, so that other people will learn. And if you have any question concerning this, you let me know. But what we're trying to do now is to explain all these topics. So by the time we go into the problem solving properly, you will be able to understand the idea behind logarithm. There are rules, and there are rules that are binding logarithm. But that same rule is what you also have in indices, right? That same multiplication rule, which was to add the index, right? Division rule, which was to add, subtract the index, and so on and so forth. So that is the general idea of, because logarithm is still an index of 10, right? You are playing around with the index of 10. Like for example, now if you're asked to say find, if you are to solve problem like this, let's say you are to find, they say, the first one, they say, let's say you are to evaluate log 3.42 times log what? Let's say 4.31, for example. 3.42, something like that, zero. Let's say we have zero, four-digit number. Now, you have to process this. Now, remember the idea of this is what is the index of 10 that will give you this. So you don't know the index of 10. So first of all, you have to check. Okay, let me reposition this thing. Let's say I have it here, for example, 334.20. Now, if you are to be processing the index of 10 that will give you 34.20, it will be a very long one, because now how do you get the index of 10 that will give you index of 10 that will give you 34 point this? It will, you won't be able to get to the answer, because we're talking about index of 10, which is very, very far, right? Now, for us to get 34. So some cannot be computed with your calculator. Your calculator is not going to compute this lengthy something. So what do we do? We convert this to standard form first, so that the number that calculator can accommodate will be lower. That is the essence of standard form that you have learned. So you see that we're applying indices, standard form, to solve logarithm problems. So they are all connected. So you need the idea of standard form. So how do we break this on standard form? We say that for 34, to break 34 in standard form, we have to say this is the same thing as saying what? 33.420 times 10 to the power of what? 1, right? Because our decimal point will move once, like we've said that before. So if you don't understand what we did there, go back and play our video on standard form. So we have done converted this in standard form, then times for this. This one is a standard form, so we don't have issues with that. So we don't write it as what? 4.31 times 10 to the power of what? 0. It's already in standard form, because we have just standard form says the point must come after the number. So that is what standard form is. Now we have reduced it. So at this point, we can easily compute between 1 and 0, right? Between 0 and 1. So our index, because we know that index or 10 index 1 is 10, right? 10 index 0 is 1, is 1. So it will be between 1 and 10 that will give us, that is, so the index that will give us this answer should fall between 1 and 10. So it's between 0 point something, 0 point something. So it will be easier for us to track this. So, but not to waste your time, just go straight to the calculator and figure out what this one is. So when you do that, you get log, when you say log 3.420, log 3.420 will give us 0.5, like I told you, 0.53. So, but remember, it is the index form. Remember the answer, this means the index of 10 that gives us this. So it has to be an index form. So 3.540, then times, we have 10 to the power of 1. So this can be in brackets, then times. The same thing goes to this, log 4.31, right? Cover, we have 0.6. So in 10 of the index of 0.6344, or I can say 5, then times 10 to the power of what? 0. So about indices, we have to add the power if the bases are the same, right? So this one plus this will give us what? 10 index 1.5340. Remember this, then times this 0 is plus, we add the indices of it, so we still have 10 of what? 0. What? 634 what? For what? 5. So by indices again, we add the power of this. So we'll be having 1.5340 plus 0.6345. So that will give us 2 point. So the answer here is 10 of the index of what? 2.1685. So it means if we are to evaluate this, the answer is what? 2.5685. That is the answer we are expecting to do. So we the same thing applicable when you are dividing, because of the when you're dividing, you subtract the index, right? We'll solve problems. We're going to see we subtract the index like we added when we are multiplying. So the same thing is applicable to when you have it in square root or in cube root. You just multiply it directly and you get your answer. If Please just try and follow us through these classes, and please help us to subscribe and share with some persons that are in SS1, so that these classes will not stop, it will continue. Thank you.